Hi, everybody. Welcome to the second segment on Chapter 4, Elasticity. In this segment, we're going to look at elasticity and total revenue revisited. We understand the relationship between price and total revenue from the last segment, but here we're going to just go a little deeper with a couple graphs. And we're going to give some examples of price elasticity and some determinants of price elasticity. And I'm going to skip over some of the little self-test quizzes and things like that. We'll be doing that in class. So elasticity and total revenue. We learned from the last segment that if you're at an inelastic point for a product, inelastic demand, and you raise price, total revenue goes up. That's the one we're supposed to remember. That's the cell phone example, and then you can back out all the other ones. Here we're going to look at the entire demand curve and take a look at how we would plot or visualize total revenue when you're going along the demand curve. Now I'll read the notes on the side of this slide afterward, but for now, let's just take a look at calculating total revenue along this demand curve as we change price. So let's look on the top, which is the demand curve, and the bottom is the total revenue. So let's go to a quantity of 2, and at a quantity of 2, we go up and the price is 8. So total revenue there is 2 times 8, total revenue is 16. Okay, so let's plot that. We go down to 2 on the lower curve and go up to a point which is right around there, 16. Okay, so let's go along our demand curve. Let's go up to 4. So at a quantity of 4, the price is now dropped to 6. But 4 times the price of 6 is equal to a total revenue of 24. Notice the total revenue is increasing. So let's go and plot that down here. At a quantity of 4, total revenue is all the way up to about 24 is about there. Okay, so we've seen this total revenue curve rise, and we see on the demand curve, yep, total revenue is indeed rising. So let's go to this middle one where we know the quantity is 5 and find out total revenue there. Well, the price there would be 5. So 5 times 5 is equal to 25. Look, total revenue increased even more. Let's go down here. Here's our quantity of 5. We want to plot that total revenue of 25, which is way up there. Here's the 25. Let's keep going. We go to a quantity of 6. We notice the price is now 4. So total revenue there would be a quantity of 6 times a price of 4. The total revenue dropped to 24. Remember, it was 25 here. So let's go down and plot that here. At 6, total revenue is falling off to 24. And now let's jump to 8. At 8, we've got a quantity of 8 times what's the price? We go across to the price axis of 2. 2 times 8 is 16. So we've got a total revenue of 16 right there. That fell from 24. So we can take a closer look at all this. I'm just going to plot it down here, an output of 8 and a total revenue of 16. So we notice along here total revenue is rising as price is falling. Here, total revenue is falling as price is falling. And we graph that here. Here's the total revenue rising to a quantity of 5 and total revenue falling. But what's interesting is now we look at portions of the demand curve. So right here, we know that if price is falling, our total revenue goes from 16 to 24 to 25. Total revenue is rising and price is falling. Well, if you go back to our previous segment, that means demand must be elastic up here. If we drop price, there's a very elastic response, so total revenue increases. Okay, so the upper portion of this demand curve from here upwards is elastic. Well, let's keep going. What if we drop the price to 4, then to 2? We see that total revenue goes from 25 to 24 to 16, and we see it on here too. Total revenue is falling off. But let's go back. We drop the price from 4 to 2, and total revenue goes from 25 down to 24 down to 16. So if you're lowering price and total revenue is falling, then demand is inelastic. That's just like if you raise price, total revenue rises. If you lower price, total revenue falls. So this is the inelastic portion of the demand curve. Well, if demand is elastic up here and it's inelastic down here, here's where it's unitary elastic. That's where elasticity equals 1. And that's at maximum total revenue. So that shows us something interesting. Where elasticity is 1, we're at maximum total revenue. I'm just going to write up here, elasticity is greater than 1 in this portion, and down here, elasticity is less than 1. So when we're in this inelastic portion of the demand curve that I'm hovering over, if we raise price, we see revenue goes up. That makes sense. When it's inelastic, you raise price and revenue goes up. If we look at this elastic portion, what would I do to raise revenue? I lower price because the quantity response is elastic and revenue rises. So we graph that here with the total revenue rising and the other side total revenue falling. So the final thing I want to point out here is price drops from 10 to 5, demand is elastic, revenue increases. They're just giving us one example. We went through the whole thing. Below, demand is inelastic and total revenue is falling. And we did that as well on this side of things. And then right at $5, demand is 1 or unitary elastic and total revenue is at its maximum. So ideally, we would love to get to the point of elasticity equaling 1 because that's where we'd be making total revenue at a maximum. So now we're going to go on and look at a range of elasticities and go from completely perfectly inelastic to perfectly elastic. Right here's our range, and chances of being extreme at either end of these are very small, but you can see over here where it says inelastic, our curve is straight up and down. That would be perfectly inelastic. Over here it says elastic, our curve is totally horizontal. So that's perfectly elastic. And in between, where elasticity is 1, our curve would be shaped like this. So don't confuse this with the entire demand curve that had the whole range of elastic to unit to inelastic. These are just little pieces of the demand curve used to help us emphasize whether something is elastic, horizontal, or very flat demand, like that, or inelastic, straight up and down, or very steep at least. So let's take a look at the loss and gain in total revenue on this. With inelastic demand, the gain in total revenue from increased purchasing is less than the loss from a drop in price. So here we drop the price from $6 to $5 and we lose total revenue of $50 on the first 50 units. 50 times 1 is a loss of $50. But because we lowered the price, we gain 5 more sales times the $5. We gain $25. So that offsets it somewhat. But the loss in total revenue is greater right here than the gain in total revenue. So if it's inelastic and you lower your price, you're going to lose revenue. We know that. The cell phone is inelastic. Let's get the companies to raise their price on cell phone plans, then they gain total revenue, not us. So let's take a look at the elastic one, shall we? I'll click ahead, 2 clicks, and this is the elastic curve that we're looking at, and we'll drop the price by the same amount. Well, with elastic demand, the gain in total revenue from increased purchasing is greater than the loss from the drop in price. So here's that $1 drop in price again, 6 to 5, and we lose $50 because we originally sold 50 units, and now in the next period, we're losing $1 on each one of those units. But look, the increased quantity demanded all the way from 50 to 80 is pretty big, so the gain in revenue is 30 new sales times that $5. That's $150. The gain in total revenue is much greater than the loss in total revenue. So here we can conclude that with this flatter curve or more elastic, if we drop the price, we'll show an increase in total revenue. So this is just kind of a more complicated way of understanding that basic idea of elasticity and the relationship to total revenue. Okay, and the last one we do is that in-between case with unit elasticity. And that's where we've got kind of the wonky shaped demand curve. It's got to be perfectly parabolic like this. I think it is. And with unit elasticity, the gain in total revenue from increased purchasing is equal to the loss from a drop in price or from an increase in price. So that unit elasticity is unique. And if we're at unit elasticity and we change our price a little bit, the loss in total revenue and the gain in total revenue from changed quantity will match each other. That's all we want to conclude for this. So we're going to look at a few examples of elasticity, and we'll get to that shortly. I just had to click a few slides that we will cover in class, but we won't cover in this video. So we're looking overall at the broad categories of elastic demands and inelastic demands, and cast your eyes on those two lists and see what characterizes those products as a group that would make this side elastic and this side inelastic. Can you kind of see over here that fresh tomatoes, you know, the price can vary wildly on those, but there are substitutes to fresh tomatoes, perhaps other vegetables. What about movies? Pretty high elastic demand. So think of the types of substitutes there might be to movies. So you raise the price of movies and people are going to do something else maybe. Think of those things. Lamb, you know, particular meat to eat. If you raise the price of lamb, would people have a lot of opportunities to buy other stuff instead? Restaurant meals, the same idea. What else could I do rather than pay for an inflated price in a restaurant? And China and tableware, well, we'll just skip that one and go to automobiles. It's elastic, so you raise the price of automobiles too much, people will substitute away. But back in the day when this slide was actually put together, scary to point out that it's 1970, the elasticity was not that high because there weren't a lot of substitutes to automobiles. Do you think the elasticity would be higher now for automobiles? Would there be more substitutes? So on the inelastic side, you'll notice here that a lot of these things, there aren't many substitutes. They're kind of necessities, but the key thing is there's not many substitutes. Household electricity, what's a substitute to that? Well, I have a flashlight, maybe not the best substitute to electricity through my whole house. Eggs, they mean eggs for cooking. If your recipe calls for eggs, there are substitutes, and more so these days, but it's pretty inelastic demand because there's not too many substitutes. Car repairs, you're kind of at the beck and call of the car repair people. Not too many people can do their car repairs on their own, so there's few substitutes. Food in general, I can't believe this is not more inelastic, because how many substitutes are there to overall food? But it still shows inelasticity. Household appliances, stoves, fridges, things like that, pretty inelastic. You can raise the price on those things within reason and people will still tend to buy. You'll lose some customers because there are some substitutes. And tobacco, pretty inelastic product because of addiction, but you raise the price too high, this is saying some people will switch away, but I suspect not very many. But there are substitutes to tobacco now, vaping, for example. So this is just to kind of give you an idea. You're probably going to be asked on an assignment to give an example of an elastic or inelastic product. It can't be one of these, and you'll have to explain why it's elastic or inelastic and give a nice description and answer to that particular question. So let's dive a little deeper into the reasons why those things were elastic or inelastic. So here, the demand for a product is more elastic, so has greater elasticity, the closer and the greater are the number of substitutes. So really close substitutes like Coke and Pepsi are really close substitutes. Again, you can't use that as an example anywhere because we talked about it too much. That would have high elasticity. Greater number of substitutes means there's all sorts of kinds of pop that could substitute. So the demand for that particular product would be very elastic. But also, the larger percent of one income that is spent on the product means it's more elastic. So for example, if I'm buying, an expensive, very fine car, or a top of the line Toyota Tundra fully loaded for $80,000, that's a big portion of my income. If you raise the price on that 1%, that represents a lot to me. So my response will be very elastic. So the larger the percentage of your income that's spent on a particular product, the more elastic that product is. Think of it the other way. Doesn't that mean that the smaller the percentage of one income, the more inelastic it would be? And just think, if I'm going through a grocery store and I'm going to buy toothpicks in the toothpick aisle, and they used to be a buck for a box, and now they've gone to $2 for a box, I don't really care. What do? I just throw that box of toothpicks right in my shopping cart and keep going. Because such a small percentage of my income is spent on toothpicks, it's a very inelastic response I have. Go ahead, raise the price, I'm still gonna buy it. Just like the larger the percentage of one income that's spent on the product, the more elastic the good is, which is the side that this slide's pointing out. And then the last thing is, the longer the time period that's involved, the more elastic the product is. Think of the demand for gasoline. Back in the 70s, when there was oil price shocks, late 70s, there was just big gas guzzling cars around. And so the price of oil went up, the price of gasoline went up, but it was very inelastic. People still had to drive their car. Even today, if the price of gasoline were to jump like crazy, well, tomorrow, just as many people would probably drive their cars into work. However, since that first big oil price shock and the price of gasoline going through the sky years ago, people have had time to adjust. Now there's a lot smaller cars available on the market. There's a lot more transit available. People are often into bike riding to work with bike paths all over the city. So just the greater amount of time. So if we're looking at the demand for gasoline this week versus the demand for gasoline over the last 10 years, or say over the last 25 years, the one that's over the longest period of time would be the one that's most elastic. So those are the key determinants of the elasticity, or the price elasticity. So the last two slides we're going to look at this, I'm not really going to go through. I would like you to pop this one up and maybe actually just look at it here, pause the video, and answer those questions. Which one of these are elastic or inelastic? And think of the determinants of elasticity that we just covered on the last slide. So do that for this slide. And for this slide, go through it and do this one. This is an excellent slide for understanding. So it says, given the following price elasticities and price changes, show how much the quantity will change, and also put it in which direction the quantity will change. Trust me, it's not as intuitive as it sounds. As well as the effect on total revenue. Will it increase or decrease? So for this first one I'll do, but I'll leave the rest for you to do. For product A, the price elasticity is 2. So if we increase price by 5%, what's going to happen to the percentage change in quantity? Well, first of all, which way is quantity going to go? If we increase price, quantity's got to go down, right? That's the law of demand. These are normal goods. But let's take a look at what elasticity is. It's the percentage change. This triangle means change, percentage change in quantity demanded over percentage change in price. So we want to solve for quantity demanded here. So I won't do the math, but all we do is take the elasticity and multiply it by the percentage change in price, and that'll give us a percentage change in quantity. So here, 2 times 5% is 10%. So I know that the price goes up by 5%, the percentage change in quantity will go down by 10% because elasticity is 2. It's a very elastic product. Elasticity is greater than 1, so it's elastic. So with an elastic product, if I raise the price, the quantity response is pretty high, so the change in total revenue is down. So that's the answer to the first one, but you should do the rest of these and go to the slides in your slide deck and find out the rest of the answers for yourself. So that's the end of this segment. We're going to go on and look at applications of price elasticity and excise tax in the next segment.